Today, we're tackling one of the most fundamental and most misunderstood parts of A-level chemistry, the three types of bonding, and what actually affects how strong they are. So in this video, we're going to break each bonding type down clearly and simply, compare their structures, look at what really controls their strength, and deal with the classic A-level misconceptions that cost marks every single exam season. And if these videos help, don't forget to like and subscribe. It genuinely supports the channel and helps other students find clear, no-nonsense explanations. Let's dive in. So let's start with what the three types of bonding are. Now let's get super clear about the 5 structure types and the 3 types of bonding. We have 5 structure types: simple molecular, giant covalent, ionic, metallic, and monatomic. That's in a separate video. Go check that out. The 3 types of bonding are ionic, covalent, and metallic. And we're going to dive into what each one of those means and what affects the strength of each of those types of bonds. So first of all, let's make sure that we know exactly what we mean when we say ionic, covalent, and metallic bonding. So ionic refers to the strong attraction between positive and negative ions. It is not about the transfer of electrons. When we transfer of electrons during chemical reactions, we create the ions, and then the strong attraction between those oppositely charged ions, that is the ionic bonding. So, strong attraction between positive and negative ions, that's ionic. Covalent is a shared pair of electrons between atoms. And metallic is the strong attraction between the positive metal ions, that are often in layers, and the delocalized outer shell electrons. Not all of the electrons in metal atoms are actually delocalized, it's just the outer shell ones. Now let's think what structure types we find these in. So we get ionic bonding in ionic substances. We recognize those via metal and nonmetals. We find covalent bonding in 2 different structure types: simple molecular and giant covalent. And metallic bonding we find in metallic substances. And again, if you want a recap of those 5 structure types, head back to a previous video in this topic. Strength of bonding now. Now, we've said that ionic bonding is a strong attraction between positive and negative ions. So one way to increase that attraction is to make the ions smaller. The other way is to increase the charge on the ion. So for example, we might have a sodium ion and a potassium ion. Both of those are 1+ ions, but the potassium ion is much, much bigger. Therefore, that would have a weaker attraction between the positive and negative ions, and therefore weaker ionic bonding. Another example could be if you have a sodium ion that is 1+ and an aluminium ion that is 3+. So that aluminium ion that is 3+ is more highly charged, and therefore it will have the greater attraction between the oppositely charged ions, whatever those might be. So the smaller the ion and the greater the charge on the ion, that increases the strength of the ionic bonding. Then we have covalent bonds. So there's a couple of things that influence the strength of covalent bonds here. The first one is the length of the bond. So usually, not always, the shorter the bond, the stronger the bond. So that could be, for example, a carbon-fluorine bond is stronger than a carbon-bromine bond because the carbon-fluorine bond is much, much shorter. The other thing to take into consideration is if you have single bonds, double bonds, and triple bonds. So usually a double bond is stronger than a single bond, and a triple bond is stronger than a double bond. And then finally, we have metallic bonding. And then finally, we have metallic bonding. So here we have the positive metal ions and the delocalized outer shell electrons. So we need to consider all of the factors that could affect the attraction between these 2 things. So the first one, similar to ionic bonding, it could be some things to do with the ion. So again, the smaller the ion and the greater the charge on the ion, the stronger the metallic bonding is going to be. However, with metallic bonding, if you have a greater charge on the ion, then that ion has also lost more electrons that are now delocalized throughout the structure. And the more delocalized outer shell electrons you have, again, the stronger the metallic bonding. So all 3 of those contribute: the size of the ion,
the charge on the ion, and the number of delocalized electrons. If you have a smaller ion, a greater charge, and more delocalized electrons, that's what gives you our stronger metallic bonding. And then finally, don't make this mistake. It is the biggest mistake that we see, getting the words confused, forces and bonds. And if you make a mistake like this in a structure bonding question, pretty much it's marked chemical error equals 0. So you lose all of your marks. So it's worth getting super clear what we mean as chemists when we say these two words at A level. So there are also 3 types of forces between molecules, and that is in simple covalent or simple molecular structures. Those 3 types of forces are van der Waals forces, sometimes called London forces, and sometimes called temporary dipole-induced dipole forces. Dipole-dipole attractions and hydrogen bonds. Misnamed, they are not bonds, they are a type of force. There is a separate video on those as well, so go check that out on my channel now. Now, those are not bonds because they are too weak. Forces are weak, bonds are strong. That's the general golden rule for A level I want you to get into your head. Forces are weak and bonds are strong. I hope this helped. And if it did, please hit like and subscribe now. Follow along for more GCSE and A level videos so that I can help you do your best and get your best exam grade.
Thanks for watching. Hit like and subscribe now so that I can help you with the rest of your GCSE or A level chemistry. Let's do this together.